It as in itself is not a data type. It's part of a greater data type that we'll explore more tomorrow. I think that's how I would consider it. But they do bring a lot of functionality to the table. Okay. Yesterday's exercise was just a little sample. I don't really feel like we got a really good opportunity to dig in too deep before I'm asking you to do some complex stuff-ish with arrays. And today's going to be not much different, unfortunately. So we're kind of learning as we go here. I took away the reading for today's class because the reading, we'll do it together today in class. And I'll actually split you guys up into groups and get you to do it and teach each other as a little bit of a different taste. Just so you don't have to listen to me talk all class and just read stuff. But one of the first things I'll do is I'll go through how to read this stuff. Because we're actually going to be working from the documentation now, starting today. Not for everything, right? But for a lot of this stuff, and it's thick, it's heavy stuff. And so it takes a lot of care when you're reading it. Okay. We had this exercise that I asked you to do yesterday. Hopefully things went okay. How did they go? How many of you nailed everything? Most of it. How many of you got most of it?
Just
Okay.
done.
All right.
Yeah.
So let's take a look. If you got all of it, if you got some of it, if you got none of it, pay attention. Okay. I'll take you through it slowly. You'll have that. Oh, okay. But make sure you ask questions. Good morning. So all I wanted you to do for this first question was just create a new array, okay? And take these variables and insert them into that array, okay? So this demonstrates a couple things about arrays, and probably something that we should already have guessed, and that is, one, I can create a new array called crew, but I'm not limited to injecting literals. Literals being a number like this, or a string like this, okay? Obviously, I can add, put in, fill up this array with variables, right? So I can say captain, commander, ensign, android, security, engineer. Right? I think I would have assumed this should be fairly obvious by now, that variables and literals are interchangeable, and that although most of my demonstrations yesterday occurred by me inserting literals into the array, we can also insert variables that contain whatever. Right? The other thing I want you to note is the syntax of the array and the spacing. So between every element, and we treat it like writing, right? When there's a comma, we put a space after the comma. Same thing as before. So when there's a comma, we put a space after the comma. If the array is getting extremely long, you can break it down into multiple lines if you want to make it easier to read. I find it gets hard with text wrapping. So this takes up more lines, but it makes it a little bit easier to read. I find it gets really hard with text wrapping if we have a really long array filled with a lot of content. Even if we were to wrap it, right, we can do that too. But I don't care for that as much. Just get a bigger screen. Okay? Any questions on that? Yeah.
Sorry, do you need to add a comma after engineering?
So if you're in line like this, you don't necessarily need to, but it's okay. You'll usually find those hanging commas off when you're going down like this. And this, like, it is the same syntax, but it's just a difference in convention. If you go and you look at people who write their arrays like this, but you know what? It's probably good practice to do it all the time because it doesn't hurt anything.
Yeah. Thank you.
Great.
I just want to know if all the elements inside of this should be capitalized.
No.
No?
Capitalized?
Yeah.
No.
Oh.
No, lowercase is fine. They can be anything, right? Because these are referring back to these variables, and variables should always start with a lowercase, they should also be lowercase,
Oh.
right? And the actual data that's in it is irrelevant, right? It's whatever you need the data to be. If you need the data to be capitalized or uppercased, then it needs to be uppercased. Otherwise, that's fine.
Oh.
Yeah. Okay.
I mean, the comma at the end is preferred to do when you have a multi when you have a string right I'll say that.
Multi-dimensional
Yeah,
array?
multi-dimensional.
No, it's not limited to that. And it doesn't really have anything to do with the
Okay.
fact that it's multidimensional. It has to do with the fact that it's easier to add more rows.
Okay.
Because every row is consistent.
Yeah.
Right? I'll be updating our style guide
Mhm.
today. So we'll have a new style guide that will include functions,
Okay.
function expressions, and arrays.
Okay.
Actually, I might wait until tomorrow and include objects as well.
We are going to work
Yeah.
with Oji.
What's that?
We are going to work with Oji in this course.
Objects?
Yeah. Before. Okay.
Yeah.
Excellent.
We're going to talk about them on a limited basis. All right, Q1. So all you need to do is change the prices of the first, third, and seventh element in the array. So I give you an array, and you need to change the prices of them. So we're going to say prices, first, third, and seventh. So the first element is which element? 123. Which means to access the first element, it's 0. Okay? So it's a little bit of a vocabulary that we need to adjust ourselves to, and that switch back and forth of talking about element numbers and indexes. Okay? So we're gonna make it 725. What is the other one? Third and seventh. So pretty much the same thing. I don't really need to look. If the third is going to be 2, right? 1, 2, 3. And we're going to make that 99, 99. And then the seventh is going to be number 6, element 6. And that's going to be 88, 88. Okay, so we're modifying an existing array. And this does not destroy the array. Okay, if we're talking about this array existing in memory, unlike strings and integers and booleans, we never actually modify those. What we do is we destroy them, throw them away, and insert something else. In here, what we're actually doing is modifying something that exists in memory. So this array is still that array. Okay, it's not a new array, it's not a brand new array. Okay. Okay. Now we're going to get a little bit more complicated. So, in this one, write a function that takes an array as an argument and uses a loop to create a new duplicate copy of the array and return it. So it's a duplicate. It's not the same array. It's a duplicate. Okay? So what we're going to do is we put this in. We provide this to a function, right, as you can see here. And out comes a duplicate. So we really end up with two of these. And they're different. Right? It's not A points to this one and to this one, and these are not equal. They are not equal. So we'll make a function called array clone. And this function, you know what? We learned about function expressions on Friday. I'm going to start using them. And we're accepting an array to clone. That is our parameter. So the parameter is an array to clone. So we're taking in an array that we want to clone. And this is going to be very similar to what we've done before. If I asked you to duplicate a string, character by character, how would you do that? Probably take one character, write it to a new string, take the next character, add it to that next string, right? Over and over and over again. We can do the same thing with an array. We can loop through this array. We take the element, the value in that element. We're not taking the element out. We're not removing it from the original array. We're taking that value out and we're copying that value to the new array. And that's it. So we're just looping over our existing array. Okay. For let x equal 0. We're starting at x. So this is kind of our first experience looping over an array with a for loop. X is less than array to clone dot length x plus plus. We need to create a empty array. This will be the copy, essentially. And then we say copy x. So the first time through this loop, this will be 0. So the first element of this new array, the 0th element, or the first element, the element at index 0, will be the same as the element at index 0 here.
Yeah.
And then when we flip to 1, the element at index 1 of copy will become a copy of the element at index 1 here. Since these are literals, that's okay. Right? We can make copies of them. And so we're making copies of them. And then we simply return our copy. And if I console log these, we'll get the exact same output as we got for an input. The difference being, undefined. No, const is fine. Array to clone. There we go. So these are the same, but they're not equal, which means they're identical, but they're not the same one. Okay, they're identical, they look the same, they're like twins. They're not, but they're not the same. They're not the one. Does everyone understand that?
Told us yesterday.
No, I know, but I'm just double checking. The difference between being the same but not the same, identical but not the same. It's hard vocabulary to. I don't think there's an accurate term for that, or that's an accurate term. But
I tried something different.
okay,
It doesn't always work. It only works when the array is inside a variable. So I didn't do the constant copy and create an empty array. I just put the loop in the function and didn't do copy X. I did just return whatever is in bracket of I or my array I.
back to here. Then you're only getting one number.
Yeah, that's what happened when it was not in variable. But if I put those ones in a variable.
No,
should
that
I
wouldn't
do
work. No, that wouldn't work. If it only works sometimes, it doesn't work. Yeah. Right?
I just wanna know if I can use for of that loop is.
Can you use for of here? Okay, well let's take a look at that. Let's switch this to for of. So we're gonna use for of to iterate. So for of allows us to easily iterate over an array. So we can iterate over this array to clone because this other one is empty, so we can't iterate over it. Right? So we can use for let element of array to clone. Now we have this element, right, which would be 1, 5, 4, 19. How do we get it onto our new array?
Index is equal.
Index?
Index is equal to the elements dot length
So index is equal to what?
equal to element
Length.
dot length
Dot length.
dot length.
Element dot length.
Yeah.
But what is element?
No, not a new add. New add.
So copy.
Yeah. Copy dot length. Copy dot length. Happen.
Copy dot length.
Yeah.
Ah, interesting. Okay. So copy copy dot length
Array.
equals element. That's interesting. Yeah, totally. I would not have thought of that. Does that make sense, right? Okay, that's a little bit of that's a reach. Okay, we gotta reach for that one. So the question is, can I use a for of loop to do this? Yes. Without pop, yes. With pop, super easy, or sorry, with push, super easy, but your goal was not to use push. Okay, so we have to walk through this. Copy.length equals element. So remember, this, let me zoom in a little bit here. This index on line 25, copy.length. Remember, that's going to, that whatever is in there needs to evaluate to an integer.
Yeah.
So what is the integer value the first time through this loop? So we'll walk through this loop a couple times. First time through this loop, what is the integer value of copy.length? What is the length of the array copy? 0. So I know this looks weird that we're using it inside of itself, but it's totally fine. Copy.length 0. So the element at index 0 in copy, which is the first element, is going to be the first element that we loop through in array to clone. So now we have copy is 1 element long. So copy.length is no longer 0. It is now 1. So when we go through the next time, copy.length is not 0 now it's 1. So it's growing. As this array grows, as we continue to add pieces on, copy.length is also growing. I like that. That's fun. Okay, I'm going to put them both up. If you don't understand this one, I strongly recommend you take a good hard look at it a little bit later. Okay?
Can I see it work?
Sure. So it returns just a copy of the array. Which looks
Sorry,
like
where did you declare the array again?
they're down here. I just declared them in line.
Okay.
But like, if I were to do this, and then I said array clone, orig, array, equals orig array. Is this going to return true or false? Oh, that was interesting. False. Even though this is what I'm asking. So I'm asking it this. Is this equal to this? And it says no, it's not. This being the original array, or sorry, this being the copy, this being the original array. Okay. We will keep rolling. The silence is uncomfortable. Clearly there is, I'm gonna just say, just from the emotion I'm getting, there's definitely a little bit of lack of understanding right now for this one. So what I would recommend is that after we're done, before you just start plowing through your next stuff, take the time to go back and look at this and stare at it until you really understand what's going on. Okay? Understand why, copy it, run it, play around with it. Okay? Don't just watch me do it, say, I don't get it, I'll never get it, or I don't get it, but I saw you do it, so I know, right, that it's not going to cut it. I did mention this was the hardest one yesterday. I still believe that. So, no?
Last one was the hardest.
Attack of the Clones. So, oh wait, no, question 3. First amendment. So this is playing on a couple of the things that we already know. So, 1, I ask you to write a function that accepts either one or two parameters. How do we write a function that accepts one or two parameters?
Write
Write
the function that is of two parameters.
a function that
Values.
accepts two parameters. Yeah. Const, and we have to call it first because we can see from our little signature there.
Oh,
First equals function, and we need to accept two parameters, an array and an element maybe, and an element. Now, why can this function, this special function, accept one or two parameters? That's not why. It is a const, and that's okay, because we're doing function expressions now. Okay, I'm going to start using function expressions because we learned it on Friday, so I want you to continue to see this syntax. The fact that it's const, right, doesn't mean anything. Why can this accept one or two parameters? This goes back to our class about functions.
Because that's the standard for JavaScript. So JavaScript
How many-
accept
How many parameters must I pass into this function?
0.
0
or
or 1 or 2? The answer is there is no amount that I must.
And
This is not a contract, right? This is not a contract. I don't have to do what it's asking me to do.
in JavaScript.
So I can pass in 0, I can pass in 1, I can pass in 2, I can pass in 10. That's the first piece, okay? If I don't pass in both of these, so let's say I just pass in an array. So let's say in this first case, where I'm only passing in an array. What is the value of element? If I don't pass in an argument to element, what is the value in element? Undefined, right? I can use that, right? If I don't have an argument there, and that element is undefined, what am I returning? The first element of the array. I just spoke the solution. If I don't receive an element, then I'm simply returning the first element of the array. Otherwise, element must be defined, and we'll assume that it's an integer. It could be a variety of other things, right? But I'm not asking you to worry about that. Otherwise, I'm asking you to return the first x elements of that array. X being 3, 2, 5, 1, whatever. In this case, 3, 7, 9, 0. So, we're doing the same thing as we did over here, where I didn't leave both of them up. So we'll have to rewrite it. For let x equals 0, x less than. This one's a little bit different. Array to clone length x plus. Sorry, I'm just re-adding this. X. But we're doing the same, pretty much the same thing down here. We create a copy, and instead of going to array to clone.length, we're going to element, or this is really size. We're going to size. How big, how many elements are we taking? We're taking size elements. 5, 3, 2, 1. And we have our array. We have our copy. So we're copying the first, the second, the third element over. Once it hits 3, we're less than 3, 2, we're done, and we return copy.
You have to change the element in your SE.
What's that?
The element in your SE.
Oh, size, yeah, size, thanks. Okay. So this is a lot of, with arrays, it's not uncommon to, this is what really trips people up, is the fact that indices are often, variables are often used as indices. These indexes on line 46, okay? Line 41, I'm sure none of you have a problem with. It's that line 46 that I'm guessing that a lot of you trip up on. Because that's, I'm the same way. This is, for me, this is a lot harder for me to make sense of than this. Especially when I'm in a loop. And these are constantly changing. Yeah.
You don't have to put console.log anywhere, not in the function and not in the call, because it doesn't print.
No, it wouldn't print. Right? The variable, so
Just one
you would
return,
have to put
okay.
console.log.
Yeah.
Now, I'm not saying prints, I'm just saying returns. If you want to check what it returns, you'd have to console.log this. Yeah. And you'd have to take this, check this out, and it does, in fact, print out 7. And we'll double check by doing this one. And it does, in fact, print out a small array. 790. Hi, Brian. Oh, yeah, here. Yeah.
This is the repetition.
Do all the, yeah,
Mm.
swipe the copier, make a bunch of
This
copies.
is from Vancouver. So the
Yep.
The constant copy,
Yeah.
network.
anything else. I put it at the first line of that function, like right beneath that.
Okay.
Which place would you put?
Here, because I don't need it outside here. Right, you don't need it outside of this else, so put it inside of the else. Thank you. Yeah. So you want to put it only in the location that you absolutely need it. Absolutely need it.
If we
You want to limit the scope. That way anyone else out there, if they really needed to, can make a variable called copy.
if we set the size default 1, when we set
Oh yeah. Okay. Oh, I like that. That's a really great way to think about this too. So we also learned about default parameters. Actually, I would do this.
no,
Because then I can just say, well, I guess it's the same thing. And then, oh, that's really nice. And then I can just do this. That's pretty good too. That's much better. That is actually way better. Yeah. Okay. Normally when I do this exercise, we haven't yet discussed default parameters, but I flipped a couple things this year. So yeah, we do have default parameters now. So with a default parameter return, remember, if I don't provide it a value, it defaults to 1. And then I don't have to check if it's 0 or undefined or 1 or 3. I can always guarantee that size is an integer. And if it's 1, which means they either put 1 or they didn't put anything, I'm just returning the first value back.
Sorry, I'm lost with size. What is it again?
Size is how many elements we want to return. there is a difference here.
对，好像
There is a difference. And the difference is this is the number 7.
对
This piece here returns a miniature array. Not a miniature array, an array. But this returns an integer. So you still have to check for something anyways. And they mean different things. So you can't really check for size equals 1, actually. You'd have to do some sort of special stuff. Does that make sense?
Yeah.
Okay. Yeah. If the rest aren't following, that's okay. Okay. Size is how many elements of the array we want to return. 3, we're returning 790. That's size. Okay? And we only exist if we pass it in. In this case, it doesn't exist. So size over here is undefined. And when it's undefined, we only want to return the first value as an integer.
Because size equals 1.
No, I erased that because size is undefined. Yeah. Because we could legitimately say this. But this means this. And this are not equal. They are two different things. Right? One is an array that contains the value 7, the other is the number 7. And so this and this are different. Which is why a default parameter of 1 does not work. I thought it did, I thought it was a really good idea, but then I actually thought about it for a second. I mean, it's not that it doesn't work, it's just that you have to do something else. Okay. Here we go. Question number 4. Write a function that accepts an array as a parameter. It's going to loop through an array and remove all the strings that are longer than 3 characters. Your function should return this new array. Again, the same thing. We're making a new array that does not contain things that have more than 3 characters. This is exactly the same thing as this one. Again. With a small twist. One, it's not called array clone, it's called less than 4. 2, we are going to the end of the let's call it what it is. It's not an array to clone. This time it's an array to filter. We want to filter out some elements. Elements that are bigger than 4 characters, 3 characters, larger than 3 characters. We want to filter those out. So we have an array that we're receiving. We want to go over every element in this array, and we only want to keep the elements that are 3 characters or less. How do we check if an element has 3 characters or less? What's that? Yeah. So how do we check? We're going through this array. We're going through this array to filter. How do we access each element in this loop? So how do I access the first element of this array in this loop? Index 0. Okay, so X, right? 0, 1, 2, 3, right? X. And how do I check to see if this element is less than or more than 4 characters.
If the fourth, which is the third index, is undefined, then it's shorter.
Yeah. Or strings have a property called length that tell you how long the string is.
Oh.
Okay. Length. So this is a string. It's this string, or this string, or this string, or this string, or this string. And alt length is the length of it. 4, 4, 3, 1, 8. So if that string is greater than 3 characters, what are we doing with it? Nothing. We're not cutting it. We're just not doing anything with it. So really it's, as long as this is less than or equal to 3, then we're keeping it. And how do we keep it? We do our copy thing. Right? Copy x equals array to filter x. And then at the end, we return copy. And that's it. So this idea of creating a new array out of an existing array is very, very classic. It's so classic, in fact, that a lot of the stuff that we're going to look at today does this for us behind the scenes. Because oftentimes, because arrays can't be changed without being destroyed, we oftentimes don't want to modify the original array that we're providing to a function or a method. We don't want to modify this. What we'd rather do is keep this and create a copy that is updated based on what we're looking for. So for example, maybe we're filtering something out. Maybe we're multiplying all the values by something. Maybe we're doing a bunch of other things, but we don't, and in the end we'll end up with 2 arrays, the original one and the updated one that has changes to it. And that's what we're doing. That's what this pattern is. So this pattern over here, this array to clone pattern is exactly that, right? All we're doing is we're creating a copy of an existing array. So we have the original array, and we have a second array that is a copy of it. In this case, we didn't make any changes to it. We just created a copy. But now we're starting to make some changes. So this array that's coming back here, it didn't destroy this first array. That array still exists, that's the original one. The updated one is a slice of it. And then in this one, same thing. This array over here that it's returning is not a destroyed, pared down version of this original one. The original one still exists. Now we have a second array that is updated. It's been modified. Okay, and it's the same pattern over and over and over again. A for loop that runs the length of the one that we want, the original one, that runs the length of the original one. And then decisions along the way to decide whether or not we want to keep those elements or we want to throw them away. So
In this case, I think there is an empty element in the array, because when the x equals 3, when x is 3, we use copy 3, but the copy 1, 2 is not, it is empty.
no, we're not checking. Okay, I see. Yes. Right. So what we really want to do then here is, okay,
Copy there.
so what Sulei's saying is that, thank you for pointing that out. When x equals 4, let's say what is the first, and this is a really good way to look at it. What is the first 3-letter string that we encounter in the array? Foo. Okay, so let's pretend we're on foo in this loop. And let's walk through this. What is the value of x? 2. 0, 1, 2. I'll rate a filter, 2.length, 3. Okay, so 3 is less than or equal to 3. Copy 2. So yeah, so the element at index 2 in copy, the first element we're going to add is going to be this. The problem is we haven't added 0 or 1, so we're starting at 2, which means we need to do that thing that we were doing before up here. Yeah, copy.length. So this is not tied to this x. Oh, that doesn't look very good, but it's fine. So this is 0, then 1. It grows on itself. So as we continue to put new elements on, it starts growing, which means this would work better as actually a for of. This works fine. Okay. If I change this to a for of, would that be okay?
Yeah.
I think it's actually a little bit easier to understand. And this is not, I like to call these what they are. It's not necessarily an element, it's a word, a string, a something, a number, a price, right? So here it's a word, so let's call it a word. And it's a rate of filter. So if the word dot length, then it's greater. I prefer this syntax.
Yeah.
To me, it's a lot easier to understand.
Yes.
Okay. Number 5, first and last. Same thing. Same thing. Okay, it's just repetition. Q4, Q5. Strings can be treated like arrays in a sense. Okay, so we can loop over a string and we can access individual characters. And so we can say const remove chars function. It's some string. And we're doing the same thing again. Except this time we don't start at the beginning. What does that mean? We don't start at the beginning. Well, I want to create a new clone of this string, but I don't want to, this is actually a little bit interesting, but I don't want to include the first or the last. So I don't want to start right at 0, and I don't want to go to length. I want to go to length minus 1. That's essentially what I want to do. So I don't want to start at 0, and I don't want to go to length, I want to go to length minus 1. So I don't want to capture that last piece. And it's not some string anymore, it's some string x.
Shouldn't we change the copy to the empty string, not an empty?
Oh yeah, thanks. Empty string, we're building a new string here. And let's bring this over here. Let's try it out. And nothing prints out because I'm not console logging anything. this out.
I have
Your
to add
copy.
it,
Why?
X.
You're on the right track. You're exactly on the right track. But I want other people to get there. Have we ever created a string, and just because we haven't done it doesn't mean we can't do it. Have we ever created a string by setting individual characters to something? No.
No.
And we can't. We can access individual characters, we can loop over individual characters and get them, but we cannot set them. We cannot assign individual characters of a string. Okay? And this might have surprised you when I said yesterday that I made this like little column up here, and I said primitive data types. And under here were numbers, booleans, a couple others, but one of them was string. And I said, in memory, we're never modifying the string. It looks like we're modifying the string when we use the plus, and like, I can add new things onto the end of the string, and it looks like I'm changing it, right? I'm not. I'm destroying that string that was in there before, and I'm creating a new string every single time. Every single time you change a string, you destroy it. Strings are what we call immutable. They're immutable. And this is pretty consistent amongst programming languages, is we're never actually changing the string, which means I can't go in and change an individual character like that. Instead, what I need to do is I need to concatenate plus equals, plus equals, plus equals. So copy plus equals. And believe it or not, every time this line happens, although I'm only adding on one character, I'm actually not adding on one character. I'm destroying whatever was in there before, and I'm saying, now you're one character longer than you were before. You're a new string that is one character long. Get out of here, old string with 3 characters. You're now 4 characters. The whole thing seems like a little bit of a waste, but that's how it works. That's how strings work. We cannot set individual characters of a string like that. They're not, we cannot set them. So we need to concatenate. We can create new strings that don't have that character in it, but we cannot just take that one character out and it still be the same string. And it doesn't like that. Why don't you like that? Oh, because it's a const. You can't do that. Because it's a string. Okay. Questions on that one? Okay. Find the largest. Little bit different this time. Not the same. Const find largest equals function. Sorry. How do we find the largest with our limited experience? What can I do? Let's talk about this. Let's talk about this. Let's not write code for this. Let's talk about this. If I gave you a list of numbers, and I'm like, find the largest. Well, you're gonna just look at that list of numbers and you're gonna be like, that's the largest. But let's talk about from an algorithm perspective. We need to write down an algorithm. We need to write down a set of words that someone could follow, some person who's super dumb, like a computer, because that's what a computer is. It's a super dumb thing, and we have to tell it exactly what to do. How would I tell it to do this thing? Doesn't have to be in computer programming terms, we can use English. To the next one? Okay, so it's always saying, go through, now you said loop, but I'm gonna pull you back and learn, we're gonna go work in just English. Okay, loop is an English word, but let's go through each character, each piece, each number, one at a time, and we're gonna take that number and we're gonna compare it to the next number. And whichever one is bigger is the bigger number. And that is now, up till now, the biggest number that we found, right? And then we take that biggest number and we go to the next number. And we say, this is the biggest number I found so far, are you bigger? And it says yes or no. And then we take that, if it is bigger, well, okay, that's the new biggest number. And then we take that and we bring it along, right? We continue to step along, going from number to number, and every time we find a number that's bigger, that's our new number. We pick that one up. We throw the other one to the side. We pick that one up, and we keep going to the next number. Are you bigger? No. Are you bigger? No. Are you bigger? No. Oh, you're bigger. Okay, yeah, you're done. We grab that one. Until we get to the end, now we've brought along the biggest number, and we don't need to check anymore. So we just go once through. The best thing is, just assume that the first number, right, if you're walking down a path, and your goal is to pick up the biggest rock on the path, and you have no rocks in your hand, the first rock you come across, that's the biggest rock, because you don't have any rocks. So that's the biggest rock you have. So you pick it up. And you hold on to that rock, and you keep that rock until you find a bigger rock. You find lots of rocks, but you don't put that rock down until you find a bigger one. And that's the same pattern we're going to use here. Right? We don't drop, we're just going to pick 19 as the biggest number, because it's the first number we found. And then we'll go and we'll step through each other number, and as long as it's not bigger, we don't do anything. 19 is still the biggest. As soon as we find one that's bigger, we say 19, we don't need you anymore. There's our output. How do we write that? How do we go through an array? How do we iterate over an array?
He said same way.
What did you? For loop. For loop. The answer is for loop. Okay? Any for loop. One of the two. Okay? Let's use for number of some array. Okay, cool. Now we're looping over it. Oh, the other thing we need to do is we need to set largest. What is largest? What did we say largest was?
Whatever is the largest.
No. We said we're walking down the path. First, 0. Right? We're walking down the path. The first rock we come across is the largest because we have no rocks. So that is, by default, the largest. So, some array, 0. That is the largest. That is the default largest. And we're going to return largest, too, because that's what this does. It returns the largest. Now, if this array is of size 1, i.e. there's only one number in it, then we got the right one. Yay! If there's only one rock on the path, then I picked up that rock first, that's also the biggest. Right? There's only one rock, I picked that one up, there's no more rocks to go over. It's the largest. Well, I would go over, but I would say, how do I compare my rocks? How do I compare my rocks? If this rock is bigger than the one I have, then swap it. So if number is greater than the one I have in my hand, largest is now number. Swap them. And we're done.
So simple.
And we console log.
就跑出它这个第一个数目。
70. Okay. And cute. Any questions on that one? Okay. Second largest. Ooh, this one's tricky. But I have a little tip. How do you know what the second largest is? Find the largest and go from there.
The largest number of the array that is not equal to the largest number.
Yeah. So, find the second largest. The largest number of the array that is not equal to the first largest. Okay, so here's what we're going to do. So in order to find the second largest, now there's better ways of doing this. There are 100% better ways of doing what I'm going to show you. But I'm showing you in a way that you can leverage what you have. And this is called a lot of the things that we're doing right now are called brute force, or BFI, brute force ignorance. We don't know of better algorithms, and I'm not expecting you to come up with brilliant one line of code, like a brilliant one line of code that just does it, or the most efficient thing. What I'm asking you to do is just brute force your way through it. As many if statements, as many for loops as you need. That's totally fine. Okay, and so there are better ways to do what I'm about to show you, but I'm not going to show you better ways. I'm going to show you a way that I think you might do. Except, I'm going to show you what lazy programmers do. Lazy programmers don't like to write things more than once. Okay? And if I need to find, the best way to find the largest, the second largest, if I'm walking down that path of rocks, the first thing I need to do is find the largest and get rid of it. Now what is the second largest? Well, if I found the largest and I got rid of it, it's the next one. It is the next largest, right? Same thing, but the first thing I have to do is find that largest and throw it out the window. So, let's do that first. Find second largest. Const. Find second largest. And we're going to get, again, some array. Okay. What is the largest? Well, we said right here. The largest is the first of the array. That was true before when we were looking for the largest, but in this case, I don't want to rewrite all that code that finds the largest. Instead, what I want to do is I just want to use this function because it already finds the largest for me. So I'm going to use that function, provide it with some array, and it's going to find the largest number for me. I just did half the work. Remember I said the first thing we need to do is walk the path, find the biggest rock, and then maybe not necessarily get rid of it, but like know what it is. Know that we have the biggest rock. And now we do. I'm being lazy and I'm reusing this instead of rewriting it. This is what good programmers do. They're lazy. I could copy and paste this and stick it in find second largest, or I can just reuse it. The beauty of functions, right?
Sorry, what does sum array do next to find largest?
It is the argument for this function, find largest, just like this,
Oh, okay.
right?
It's like a for a?
It is this array, right?
Okay.
This goes into here, which is now a variable containing an array. I'm passing it to find largest. Okay. It is a variable containing an array, and then I'm taking that variable and I'm providing it to this function over here.
Okay.
Okay. And it's going to return a number. The largest of this array, which is 89. Now all I have to do is loop through this array and find the largest number, the second largest number, that's not 89. So loop through. So we're just started at 0.
What if you put negative numbers to compare?
You can start from negative infinity.
What's that?
You can start from negative infinity.
Yeah, like I said, this is okay, first of all, this doesn't cover everything. There's a lot more complex stuff, but I'm not asking for super complex stuff. Yeah, technically I need to start at negative infinity, right? Because what if it's negative 9,999,000, right? So, does it say positive integers? No, I should say positive integers. Yeah. But I would just start at 0. I would say positive integers starting at 0. And I would say if number is greater than second largest and not equal to number not equal to largest, then second largest is that number. Oops. And number not equal to second largest. So now if we take this whole thing, right, so it's bigger than the second largest, which we just default to 0. 0. And it's not 89, because we've already defined 89 is the biggest number. We did it right here, line 110. This found 89 as being the biggest number. So it's not 89, and it's bigger than 0, and it's bigger than, or it's bigger than the second largest, which was 0, then it was 28, 28, 28, 41, 41, 41, 41, 67. So we take this whole thing, because we need that other function too. Undefined. I need to return something.
Let me check.
Yes.
I tried that before. It
Yeah.
works with numbers that aren't minus or plus 0.5.
Yeah, okay,
And
so I'm
decimal
gonna change this
equals-
question to be positive integers. Positive integers. Like, you can kind of tell from what I'm providing here, to a certain degree, like what I'm looking for. Yeah, it gets really dicey when you're doing negative numbers, because like I said, you can have this number in there. And now that's 0 doesn't cut it anymore. And you can't just pick the first one, because the first one might be the largest. So you'd have to, well, you can do a check. You can say, if first equals largest, but then you can have, then go to the second, then go to the third. So you might have a second loop that picks not the first non-largest. It gets a lot more complicated.
I tried creating an empty array for the second largest and put every number in without order that is smaller than the largest. And in the return, I returned the largest function and second largest array as in the array.
I'd have to see it.
Or
I mean, really the best way to do this is to sort the array. But sorting an array is not easy.
And then is
Questions, comments, concerns?
Can you show me the difference again of how like 6 and 7 returns just one value, and the other ones that we did earlier collects all the elements.
Okay, so I mean, it really comes down to what we're doing here. Second largest is an integer, and that is what we're returning. So it only returns an
One.
integer,
Yes, and
one value.
and it doesn't collect everything that you're returning. I'm like,
No, whereas over here, copy, which is what we're returning, is an array. And so you can kind of tell by
Okay.
going back through it, like, oh, copy. Okay, we use returning copy. Well, what's copy? He's declaring copy as an array, which means it's probably an array. Let me just double check. Oh yeah, so he's copy, he meaning me, right? So he's doing copy this index, copy this element equals that element, and he's returning that. So you can see that I start off with an array. I'm
Okay.
doing array-based stuff, and then I'm returning that array. So it's that collection. I'm collecting
okay,
things.
so to collect, you have to declare it as an array.
You don't have to, but you should. There are other ways of doing it, but yeah, most of the time, yeah. Most of the time, yeah. Yeah. So you can usually tell by how the array, you can usually tell what is being returned by how the variable was declared. This is unique to not unique to JavaScript. This is unique to a style of languages in that JavaScript belongs to, and that is the type of languages that don't require you to specify a type. In other languages, for example, when you go back to C#, your function is going to say what type it's returning right in the function name. It will say, for example,
int.
array. And so you know that it returns an array because it says right here it's returning an array. And so that makes it easy to identify, but that's also a contract, meaning that even if you wanted to return something else, you wouldn't be allowed to. So there's no flexibility. So JavaScript is very flexible because we don't operate on that sort of same contract, where it's like, this is what you said it's going to be, right? Like, if I wanted to, in this next line here, I can say copy equals 5, right? Is there anything in line 61 that says copy must be an array? And I can only insert things into that array. There's nothing, right? Because now the next line after that, I can say actually copy equals John. There is nothing binding me to saying this box, copy, contains an array. Remember, boxes can contain anything. And I can empty them out and put anything back in after. But in other languages, if you have a box that holds an array, that box can only ever hold an array. Or that box can only ever hold an integer. In JavaScript, the boxes are generic, they can hold anything. And we can dump them out, put something else in. And so those are differences. This provides flexibility. I can put anything I want in there. So you do kind of have to be a little bit careful because it can be a little bit more difficult to figure out what's going on. Because yes, while I did declare copy as an array, and I'm returning copy, you also have to know what's going on in between to really make sure that that's what's happening. But you can always just run the function and check the return value and see, oh, it's an array. So there's a lot of different strategies you can use to really figure out whether or not it's a collection or whether or not it's an integer. Right? One, check what are you returning, second largest, check for declaration, second largest looks like an integer, so it's probably going to be an integer. If I run this function, what do I get back? Oh, I get back an integer. Okay, so those are some clues that help me identify that it's an integer as opposed to a collection. That's it, as opposed to a collection. As opposed to a collection.
So if you declare an array here, it will just collect all the numbers.
No, because I'm not. I remember, as a programmer, I have to tell it to collect the numbers. It doesn't just collect numbers. I have to take the number from one array and move it onto the other array. I have to manually do that. And this does not do that. So I would have to change this too. Right? It doesn't just, if I declare it as an array, it doesn't just collect them for me. It has to be told how I want them collected, how I want them ordered, which numbers to bring over. It needs to be told everything. Absolutely everything. And so take some time to look at the difference between this one and this first one, this array clone, which has two different variations, okay? This is kind of the basis for taking one thing, building a new collection out of it, and returning that new collection. It's really, this one is really important to understand. Okay, this demonstrates everything. Creating a new array, iterating over that array, taking an element from that array, setting it to the element of another array, and returning. This is everything right here. And then finding the largest is an excellent example of not creating a collection, but extracting something from an array. So these two, question 6 and question 2, are excellent questions to study and to really understand what's going on. If you get those two, you should be able to get everything else, because everything else is just, it's like the same pattern, it's a related pattern. Okay. Let's take a break, come back at 10:25, and we'll work through the afternoon with some more array stuff.